In this video, we're going to look at trigonometric identities, revision of National 5 trig identities, and we're proving the following. So the way we set this out is very specific for proofs. So we look at the left-hand side being LHS equals, and we have sine cubed x plus cos squared x sine x. And we're going to do some work and hopefully end up with sine x as our answer. So this is the way we set out proofs, so don't start trying to rearrange between the sides because we'll just get muddled. Okay, so we want to aim for sine x. I do glance at my right hand side to help me out a little bit. So ideally, I don't want to have any coses in my expression. So I need to think about my identities. So your trig identities from National 5. I cut my screen down in the middle here. My trig identities, we've got sine squared x plus cos squared x equals 1. There's also the identity sine x over cos x equals tan x, but we don't want to introduce tan, so this is the one I'm going to work with for this one. So ideally I want to replace cos squared x with something. So let's make cos squared x the subject of the formula. So you want it on its own. So we get rid of sine squared x by subtracting it from both sides. And you can write out a new identity, something that's true. Cos squared x equals 1 minus sine squared x. You may have been taught from your National 5 teacher just to learn off sort of separate identities. So you might have learned off sine squared x plus cos squared x equals 1, and cos squared x equals 1 minus sine squared x, and sine squared x equals 1 minus cos squared x. I tend to only work with the ones, so there's less memorizing to do, and then just rearrange depending on what will help me out. Okay, so I'm going to replace this with 1 minus sine squared x. So we have sine cubed x plus, and I'm going to bring this sine x to the front and then put in my cos squared x, just because we're used to our brackets being like that. If you had substituted in 1 minus sine squared x and had the sine x after the bracket, that's absolutely fine as well, but it just makes it more natural to expand our bracket now like this. Okay, so we have sine cubed x plus sine x times by 1 is sine x. Take away sine x times by sine squared x. So it's like an x term multiplied by an x squared term. Gives us a cubed term. So sine cubed x. And then you should hopefully notice that sine cubed x take away sine cubed x cancels out. Anything take out itself as 0. So you're left with sine x, which equals your right hand side as required. And you're done.